dy dx equals this stuff here, for x not equal to 0. Given that y equals 7 at x equals 1, find y in terms of x, keeping each term in its simplest form. So here's the problem then. So let's have a look at it then. We need to separate the variables and integrate. So separating the variables and integrating. Gives. Okay, leave the dy as is then, and move the dx up to be on this side here. Minus x cubed can stay as is. This can be split up into its two constituent parts of the fraction, so it's 4x over 2x cubed, and that term over the 2x cubed will leave 2 over x squared plus 2 over x squared. Then let's write that down straight away, minus 5 over 2x cubed. And then we move the dx up to be with it. Separate the variables and integrating. This dy is really one lot of dy, isn't it? So let's put that down explicitly. So the only thing that might be slightly confusing is this bit here. So we just split this fraction up, 4x over 2x cubed, and I wrote that down as 4 over 2 is 2, x over x cubed is an x squared underneath, minus 5 over the 2x cubed. So that's fine. Integrating then, 1 dy integrates to y. Power rule, minus raise the power by 1, divide by that number. This is x to the minus 2, so we're going to have x to the minus 1. When we differentiate this, we'll have minus this to the minus 2. We don't want a minus, so we need a minus there. And we also need a 2, so it's minus 2. And then this is x to the minus 3, so raise the power by 1. X to the minus 2. When we differentiate, the minus 2 comes down, so the minus is okay, so put a plus here then. The minus 2 comes down, we want 5 over 2, so we'll need 5 over 4, won't we, so that one of the 2's will cancel here to give us the 5 over 2 with a minus. Plus constant of integration then. So that's the integration done. The initial condition y is 7 at x equals 1. Y equals 7, x equals 1 gives, let's see what we get then. 7, x is 1, 1 to the 4 is 1, so this is minus 1/4. Minus, the x underneath is minus 2 over 1, which is minus 2, and then plus 5 over 4, and the x comes down, x squared, that's just 4 lots of 1 squared, which is 4. Plus k. So this is just the number 2, so I'm just going to replace that with the number 2 here. So that tells us then. So we got 5/4 minus 1/4 is just plus 1. So we've got minus 2 plus 1, which is minus 1. Move that over to be with the 7. Minus 1 moved over is 7 plus 1 is 8. So k equals 8 then, we can see that. So our initial condition, our particular solution then, y is equal to minus x to the 4 over 4, minus 2, and I'm going to put this underneath now as x to the 1, plus 5 over 4x squared, just seems easier on the I, plus our k value, which is 8. And that's the solution to the differential equation.